The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
So I'm going to start by the first step of the reaction, which is basically nucleophilic attack. It's a nucleophilic addition process, and what we have happening here is that our acid attacks or adds to thionyl chloride, which I'm just going to draw in red right there to give it a bit of a different look. So what happens in this case is our acid will use a pair of electrons on its oxygen atom to add to or attack that thionyl group right there. So that will give us an intermediate that looks something like this. Just going to draw that out one more time, make that more clear. As you can see, it's a pretty bulky intermediate. It's a charged intermediate as well. So you can see we have a negative charge in that oxygen right there. And that's pretty much what the first step looks like. So it's basically nucleophilic attack. So that is step one. What happens in the next step is that the leaving group will then exit. It will leave the structure of the intermediate. And how that happens is very simple. A pair of electrons, this intermediate is going to collapse. A pair of electrons is going to come down to restore the thionyl group, to restore the double bond between the sulfur and the oxygen. And as that happens, a chloride ion is simultaneously going to leave or exit the structure, resulting in the formation of yet another intermediate that looks something like this. So I'm just going to quickly draw that out. This is still another charged intermediate in that it has a positive charge on one of its oxygen atoms right there. And as you can see, that's a group right there. So this is pretty much what happens in the second step of the reaction. We have the exit of the leaving group. It's an elimination process. So in step two, we have elimination. Okay, so what happens in the third step is that that intermediate we just formed will then be deprotonated by the very chloride ion that was eliminated from its structure. So I'm just going to quickly once again draw out the intermediate that we finished with on the previous slide. So the chloride ion is going to come along. Remember, it just exited, it just left the structure, and it's going to abstract or remove a proton from that intermediate, which results in the formation of yet another intermediate, this time a neutral one that looks something like this. Just going to quickly draw that out. Awesome. Okay, so the reaction is not over at this point in time. Yet another nucleophilic addition process, yet another nucleophilic attack will occur after this deprotonation. And this second nucleophilic addition is also once again effected by another chloride ion that then actually adds to this intermediate of ours. So I'm going to quickly draw that. Okay, that's going to be another chloride ion right there. That is then going to add to the carbonyl group. Remember, that center right there is very electrophilic, resulting in the formation of a compound that looks something like this. I'm just going to continue drawing that in red. to make that completely clear for you guys. There we go. Now this other intermediate that's formed is also charged. There's a negative charge on this oxygen atom right here. And what happens next is that this thionyl group right here, that entire SOCl group, is a very good leaving group. So what's going to happen is that this intermediate will then also collapse to expel or remove the thionyl group. So a pair of electrons will come down from that oxygen atom to restore the double bond between the carbon and the oxygen, to restore the carbonyl group. And as that happens, that thionyl group will simultaneously exit with a pair of electrons as well, resulting in the formation of what is essentially our final product, or final generic acyl halide that looks something like that, as well as a byproduct that looks something like this. Now this reaction is not complete. Remember, one of the key byproducts of this process is sulfur dioxide gas. So what's going to happen is that we'll have one more electron migration right here from this oxygen, which results in the formation of a sulfur dioxide gas, and obviously eliminates another chloride ion from that byproduct intermediate, resulting in the formation of what are the final products of our reaction, which is our acyl chloride, sulfur dioxide gas, and chlorine, and the chloride ion. So this is our acyl halide.